Hi Year 12, this is our third video for the solutions to the 2021 Extension 1 Maths HSC exam. In this video we will look at questions 13 and 14. 13a. A 2-metre high sculpture is to be made out of concrete. The sculpture is formed by rotating the region between y equals x squared, y equals x squared plus 1 and y equals 2 about the y-axis. Find the volume of concrete needed to make the sculpture. So our formula we're going to use is this one, between a and b, of x squared dy. What we're going to do is work out the volume of this lower function, which is the y equals x squared one, and then subtract this volume in here. So our limits are going to be, the outside function is going to be between 0 and 2, but this one here, it starts at 1. So let's set up this integral. Volume is equal to pi, integral between 0 and 2 of x squared, which is y, dy, take away pi, integral between 1 and 2. I want x squared, so I need to make x squared the subject. So that's equal to y take 1, y take away 1, dy. Integrate. It's y squared on 2, between 0 and 2, take away pi, y squared on 2, take away y, in between 1 and 2. Substitute the 2 in. So I get pi, 2 squared is 4 on 2, take 0, take away pi. Substitute the 2 in, I get 4 on 2, take away 2, take away, and now substitute the 1 in, a half, take away 1. That's equal to 2 pi, take away pi. 2 take 2 is 0. What do we have here? Negative times negative a half. Okay, so sorting that out, we have 2 pi, that's cancelling, take away pi on 2, which is 3 pi on 2 units cubed. 13b. When an object is projected from a point h meters above the origin with initial speed v at an angle of theta to the horizontal, its displacement vector t seconds after projection is this. A person standing in an empty room, which is 3 meters high, throws a ball at the far wall of the room. The ball leaves their hand 1 meter above the floor and 10 meters from the far wall. So something like this. The initial velocity of the ball is 12 meters per second, and it's thrown at an angle of 30 degrees to the horizontal. So the ball will not hit the ceiling of the room, but it will hit the far wall without hitting the floor. So 2 things to do. Let's start with this one. Will not hit the ceiling. So we need to know what the maximum height is, and that's going to come from working out the velocity vector. So v of t will equal v cos theta I plus negative 10t plus v sine theta j. Now we know a lot of these constants, don't we? V is 12, theta is 30 degrees, so cos 30 is root 3 on 2i, plus negative 10t plus v is 12, and sine 30 is a half. J, tidying it up, 6 root 3i plus negative 10t plus 6j. So we need to work out when this is equal to 0. So negative 10t plus 6 is equal to 0. 10t is equal to 6. T is equal to 0.6. Now we're going to substitute that in to our expression for y to find the maximum height. So y of 0.6 will equal negative 5, 0.6 squared plus v is 12, t, sine 30 is a half, and h is 1. Okay, on the calculator we get negative 5 times 0.6 squared plus 12 times 0.6 divided 2 plus 1 is 2.8. So the maximum height is 2.8, but the ceiling is at 3 meters. So therefore the ball won't hit the ceiling. And then finally, we want to prove that it will hit the far wall without hitting the floor. And that's going to come from working out the range. So we're going to take our y coordinate there and put it equal to 0. 0 is equal to negative 5t squared plus 12t, sine 30 is a half, plus 1. 5t squared take 6t, take 1 equals 0. T is equal to 6 plus or minus the square root of 6 squared is 36 minus 4 times 5 times negative 1, all over 2 times 5, which is 10. Now, we want the positive one there. The negative one will be negative, will give us a negative time, which we don't want. So 6 plus the square root of 36 plus 20, all over 10, gives us 1.35 seconds. Now, to work out the range, we need to substitute it into the x coordinate. So that's going to give us x is equal to 12 times 1.35 cos 60. So 12 times 1.35 times root 3 on 2, which is 12 times answer times root 3 divided by 2, which is 14.01. And so given that that is greater than 10 meters, then therefore the ball will hit the far wall. 13c, the region enclosed by this here, which is those two straight lines, and this, which is this guy, is shaded in the diagram. Find the exact value of the area of the shaded region. Now we're going to have trouble integrating this with an absolute value, but I can see that these two areas are symmetrical. So I'm actually just going to take this area 2 and double it. So our area will be 2 lots of in between 0 and 2. I want this here. That's going to be 2 minus x. Take away this bit here, which is 1 take away 8 on 4 plus x squared dx equals 2. Let's tidy that up first. 2 take away x, take away 1 plus 8 on 4 plus x squared dx equals 2, 0 and 2, 1 take x plus 8 over 4 plus x squared dx is equal to 2 lots of x take x squared on 2 plus 8 inverse tan of x on 2 divided by 2 in between 0 and 2, which is equal to 2. Now let's substitute in 2. We've got 2 take away 4 over 2 plus 4 inverse tan of 1. Take away 0 minus 0 plus 0 is equal to 2. Outside of 2, take 2 is 0, so 4 inverse tan of 1 is pi on 4. And it's equal to 2 pi. 13d, part 1. The numbers a, b and c are related by the equations a equals b minus d and c equals b plus d, where d is a constant. Show this. Okay, we'll start with the left-hand side. Is equal to sine a, so sine of b take d plus sine b plus d all over cos b minus d plus cos b plus d. All right, let's do these expansions. This is sine b cos d minus sine d cos b plus sine b cos d plus sine d cos b all over cos b cos d plus sine B sine D plus cos B cos D minus sine B sine D. Alright, that cancels out, and this cancels out. So I end up with 2 sine B cos D over 2 cos B cos D, cancel, 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 is equal to tan B equals right hand side. Part 2, hence or otherwise solve this awful looking thing. So in this case 5 theta on 7 will be A and 6 theta on 7 will be C. And we want to turn it into tan B. But we've got this D, which is annoying, so we need to get rid of it. Make D the subject. That is B take away A, and substituting into this one, C must equal B plus B take away A, which is 2B take away A. Making B the subject, 2B is equal to A plus C. B is equal to A plus C over 2. So substituting in, we've got 5 theta on 7 plus 6 theta on 7 divided by 2, which is 11 theta divided by 7 divided by 2, that's 14 on the denominator. Wow. So instead of all of this now, we can just do tan B. So therefore, tan of 11 theta on 14 is equal to root 3. So 11 theta on 14 is equal to inverse tan of root 3, which is 60 degrees, so pi on 3. And we need the other quadrant, which is down here, pi plus pi on 3, so 4 pi on 3. Now, 11 on 14 is close to 1, so I don't think we'll have any trouble with needing, further solutions. I think we can just leave it at that. So just tidying this up, theta will be 14 pi on 33, and 4 times 14 is 56 pi on 33. Question 14a. A plane needs to travel to a destination that is on a bearing of 063. So this angle is 63 degrees. The engine is set to fly at a constant 175 kilometers per hour. But there is a wind from the south with a constant speed of 42 kilometers per hour. On what constant bearing to the nearest degree should the direction of the plane be set in order to reach the destination? So if the plane flies on a bearing of 63, it's going to be pushed off course. It's going to be pushed in the direction of that green vector. So we need to adjust. It needs to fly down here so that when the south wind comes, here is its path, and this is 63 degrees here. So this is 175 and this is 42. Now what else do we know? We know that these are alternate angles because this wind here is directly from the south. So that makes this angle 63 degrees, and we want to work out this angle here. And just comes down to sine rule, doesn't it? Sine theta over 42 is equal to sine 63 over 175. So sine theta is equal to 42 sine 63 over 175, which is equal to, make sure my calculator is in degrees. It is 42 times sine 63 on 175 is 0.2138. 0.2138. So theta is equal to inverse sine of 0.2138, which is 12.3 degrees. So that's in there. So the bearing is going to be 12.3 plus my original 63, which is 75.3 degrees, and we want it to the nearest degree, so that's 75 degrees, or 0.75 degrees. 14b. In a certain country, the population of deer is estimated in 1980 to be 150,000. So make that t is equal to 0. Population growth is given by the logistic equation. T is the number of years after 1980, C is the carrying capacity. In the year 2000, so this is T is equal to 20, population of deer is estimated to be 600,000. Using this fact, show the carrying capacity is approximately 1.13 million. Okay, so we're going to start off by trying to integrate this. I've got dp dt is equal to 0.1 p c minus p over c. Let's turn that upside down. dt dp is equal to 1 divided by 0.1 is 10. So 10 on p, c over c minus p. So we have got 10 c over p, c minus p, and we're given this, which means I can split this up. It will give me, actually I'm going to do the integral. T is equal to 10 integral of c on p, c minus p dp, which is equal to 10 integral of 1 on p plus 1 on c minus p dp equals 10 ln p minus ln c minus p plus, let's use d for the constant, which is equal to 10 ln p over c minus p plus d. Now at t is equal to 0, the population is 150,000. Substituting it in, and go over here, 0 is equal to 10 ln 150,000 over c minus 150,000 plus d, and so d is equal to negative 10 ln 150,000 over c minus 150,000. Therefore, t is equal to 10 ln p on c minus p minus 10 ln 150,000 on c minus 150,000. Okay, let's try and tidy that up. Equals 10 as a common factor, ln. Now we're going to end up with an almighty mess here. P on c minus p divided by 150,000 over c minus 150,000 is equal to 10 ln p c minus 150,000 on 150,000 c minus p. Okay, in the year 2000, the population was estimated to be 600,000. So this is t is equal to 20. So 20 is equal to 10 ln. P is now 600,000. C we don't know. All over 150,000. C minus 600,000. Okay. Dividing by 10. 2 is equal to ln 600,000. C take away 150,000. All over 150,000. C take 600,000. So e to the power of 2 will equal 600,000 C take away 150,000 all over 150,000. C take 600,000. Okay, so we get 150,000 C take 600,000. E squared is equal to 600,000 C take away 600,000 times 150,000. 600,000. Watch all those zeros. 150 equals 9 times 10 to the 10. 9 times 10 to the power of 10. 150,000 E squared C take away 150,000 times 600,000, we just did that, 9 times 10 to the power of 10 e squared is equal to 600,000. C take 9 times 10 to the power of 10. Collecting those c's together, 150,000 e squared take 600,000 is equal to 9 times 10 to the power of 10 e squared take away 1. And so C is equal to 9 times 10 to the power of 10 e squared take 1 all over 150,000 e squared take away 600,000. Alright, what are the chances? On the calculator we get 9 times 10 to the power of 10 bracket e power of 2 take away 1 close brackets on 150,000 times e power of 2 take away 600,000. 2, 3, 4, 5, 6. Which is, oh my goodness, I actually got it right. 1, 1, 3, 1, 1, 2, 1, which is approximately equal to 1,130,000. 14c. For vector v, show that v dot v is equal to mod v all squared. So I'm going to let the vector equal ai plus bj. So starting from the left hand side, v dot v is equal to a squared plus b squared. And that's the same as the square root of a squared plus b squared all squared, which is equal to mod v all squared. Part 2. In the trapezium ABCD, BC is parallel to AD and the magnitude of AC is equal to the magnitude of BD. Let the vector A be AB and the vector B be BC, and the vector AD is equal to K times BC, which say KB. K is greater than 0. Using part 1 or otherwise, show this. Okay, so we're going to start with this fact here, that AC is equal to BD, the magnitudes, which means that the dot product of AC and AC will equal the dot product of BD, BD. Now AC, let's see what is that. That's AC there, so that's A plus B, vectors A plus B, dot A plus B, and BD, that's here, so that's going to be negative A plus KB, KB minus A, dot KB minus A. Expanding, we get A dot A, which is magnitude of A squared, plus 2A dot B plus magnitude of B squared is equal to K squared, magnitude of B all squared, minus 2K A dot B plus magnitude of A squared. So that cancels out, and we get 2 plus 2K lots of A dot B equals K squared B minus B magnitude B squared. It's just 2K plus 1 A dot B equals K squared minus 1 B magnitude B squared. Divide both sides by K plus 1, get 2A dot B, and I'm going to factorise this. K squared minus 1, that's K minus 1, K plus 1, all over K plus 1, mod B squared. They cancel out, and just tidying it up, 2A dot B take away K minus 1 mod B all squared is equal to 0. Therefore, 2A dot B plus 1 minus K mod B all squared equals 0. Under certain factory, the proportion of faulty items produced by a machine is this, and that's considered to be acceptable. To confirm the machine is working to standard, a sample size of n is taken and the sample proportion is calculated. It is assumed that the sample proportion is approximately normally distributed with mu is equal to p, so that's 3 over 500, and variance given by this. Production by the machine will be shut down if the sample proportion is greater than or equal to 4 on 500. Sample size is to be chosen so the chance of shutting down the machine unnecessarily is less than 2.5%. Find the approximate sample size required. Okay, so let's start by working out our variance. So that's going to be 3 on 500 and then 1 minus 3 on 500 divided by n because we don't know n. And tidying up that numerator, we get 3 divided 500 times 1 minus 3 divided 500, which is equal to leave it as a decimal, 0.005964 over n. Now, we know that this is approximately normally distributed, and it has mean of 3 over 500. I'm just adding on our standard deviations. The sample size is to be chosen so that the chance of shutting down the machine unnecessarily is less than 2.5%. We know that 95% of data in a normal distribution lies within 2 standard deviations of the mean. So this little bit here is 2.5%. So this is one standard deviation, and here's the second standard deviation. So we want 3 over 500 plus 2 standard deviations to be less than or equal to 4 over 500. In other words, 2 sigma has to be less than or equal to 1 on 500. Sigma has to be less than or equal to 1 on 1000. Now we don't know sigma, but we do know sigma squared. So we're going to do the square root of 0.005964 all over n. I'm going to drop the inequality sign and just work with an equal sign. I can interpret it at the end. So squaring both sides, we get 0.005964 over n is equal to 1 over 1 million. And so n is going to be equal to, actually I'll do it, just flip it upside down, 0.005964 equal million. And so, just timesing both sides by that 0.005964 number, we will get this which is 5,964. So that's the sample size required. And last question. The polynomial g of x is equal to x cubed plus 4x minus 2, and it passes through the point 1, 3. Find the gradient of the tangent to f of x if that's equal to x multiplied by inverse g at the point where x is equal to 3. Alright, so let's start by differentiating this. I'm going to use the product rule. We're going to let u equal x and v equal inverse g. So we're going to get x multiplied by the derivative of the inverse function of g plus 1 times inverse function of g. Okay, and we're wanting this when x is equal to 3. Now, the first thing that we know that is if g of x passes through the point 1, 3, then the inverse function passes through the point 3, 1. So this is going to equal 1, and that's going to be important for here. But the second thing is this. We need to try and work this out. So we'll start by saying let y equal x cubed plus 4x minus 2. Let's form the inverse relation. So x is equal to y cubed plus 4y minus 2. Now we can't make y the subject there. But what we can do is dx dy. So I'm differentiating this with respect to y. That's 3y squared plus 4. And so dy dx is equal to 1 over 3y squared plus 4. So what we need is the value of inverse function of g at x is equal to 3, that derivative, if that makes any sense. Now we know when x is equal to 3, y is going to be equal to 1. And so this is going to be equal to 1 over 3 plus 4, which is 1 on 7. So f dashed of 3 will be equal to 3 multiplied by 1/7 plus this here, we want inverse function of g of 3, which is 1, which is 3/7 plus 1, which is 1 3/7.